we are going to see a lot of our alphabet being used. Okay, A, B, C, D, alright, and then X, Y, Z. Okay, a lot of letters are going to be used. Alright, so all these letters that we use, okay, so things like A, B, C, X, Y, Z, okay, of course there are more. Okay, we have more letters in our alphabet. Okay, these are all going to be used to represent, okay, certain things. Okay, things, for example, like your specific unknown numbers. Okay, and then maybe generalized numbers, a general situation. And then, more importantly, we usually call them variables. Okay. So I believe, for example, in primary school, okay, you might encounter questions such as 3 times a box equals to 12, and they ask you to fill in this thing in a box. What should be in the box? 4, right? Okay, I think we all know that. So instead of using a box itself, okay, in our secondary school and our future journey, instead of using a box, we are going to use a X to represent it. Then the question will be, what is the value of X? And very clearly, just now we already know that X is equals to 4. Okay? So this is what I mean by using letters to represent unknown numbers, okay, to replace the box that we used to see. Okay? But before we go into answering questions like this, okay, we need to develop some basic concept, basic understanding about how, okay, algebra is going to be used. Okay? So first thing, algebraic notations. Okay? When I write it in a certain way, it must actually mean a certain thing. Yes, and go. Okay? So notation. Okay, so if I write it as 3x, what does it actually mean? What do you think it means? 3 times x. Okay, so it means 3 times x. By the way, when we write x, notice how I write it. Okay, I write it like there are two C's that are mirror to each other. Okay, I write it like that. You need to differentiate your multiplication and your x. Okay, you cannot use the same way of writing. Otherwise, nobody is going to know and understand what you're trying to say. Imagine you're trying to write 3 times x times x times x. How am I going to understand what you're writing? To me, when I read this, I'm like, are you giving me a secret code? Okay, so we need to differentiate, okay, all your multiplication signs and your x itself. Okay, so first of all, 3x means 3 times x, and we know 3 times x, okay, means 3 groups of x. It also has the same meaning as x plus x plus x. Agree? Okay, so they have the same meaning. Sometimes there may not be numbers involved, okay? There may be 2 letters sitting side by side to each other. For example, x, y. Okay? By the same logic to my representation earlier, x, y will have to mean x times y. Okay? So it can actually mean x times y. If I want to think about it in addition, it will mean that y plus y for x number of times. Or I can see it as x plus x for y number of times. That is our understanding about how multiplication and addition is like. Okay? Right? Then continuing over here. squared. We have already learned this index notation, okay, when we were at chapter 1. So x squared means x times x, because we know 5 squared means 5 times 5, right? So x squared will mean x times x. Okay, so x times x is not the same as 2x or even 3x. Okay, likewise x cubed will be x times x times x. Okay. So I really want to emphasize that we don't usually write the multiplication sign. Okay, so when we write as 3x, we just mean that it's 3 times x. That is a convention. That means everybody recognize it the same way. Okay, so no need to write 3 times x anymore, you can write 3x. But of course, if you want to say things like 4 times 5, can I put 45 to mean 4 times 5? No, okay, because that only applies to our algebra, doesn't apply to our numbers. Okay, because 45 is 45, 4 times 5 is 4 times 5. So what we do in algebra doesn't quite extend to our numbers idea. Okay, so that's one thing. Another important thing is that if I really want to say 1x only, okay, so this is one very important one. We do not write 1x. Okay, we just write x to represent that. So writing x alone without the 1 in front of it will tell us that there is only 1x. Okay, don't need to be so insistent on writing that 1. Right, so if you continue to keep writing that 1, I'm going to penalize you for presentation. Okay, because nobody is going to accept this at all. Okay, one. We just write x. Sorry, my bad. Thank you. Okay, questions? Clear? Okay. Now let's try some examples. Okay. What if I have 2n? Okay, what does 2n means? Okay, let's choose someone to see. What does 2n means? N plus n, okay, what else can it mean? Or maybe I should say a person, Lucas A. Where is Lucas A now? There, right? Lucas, can you tell me 2n, what else can it represent other than n plus n? Sorry? 2 square, n square. Lucas A say 2n is n square. Sure or not? No. Okay, yes, Kaylin, yes. 2 times n, right? Okay. N square, okay, Lucas, n square means n times n. Okay. It is not the same as 2n or 2 times n. Okay. What about if I use AB? Okay, what would AB actually mean? Colleague. What does AB mean? A plus B, you sure? Look at what I previously wrote already. Don't go into this one, okay? Do the more simplified version. I pointed it to you already, so xy we know it means x times y. It should mean yes, A times B. Okay? Right? Next, okay, what if I have A over B? Okay, let's choose Lucas arm. A divided by B. Okay, and then just now I already addressed that x squared means n times n. Okay, now what if? Now I give a slightly trickier one. Okay. Erase this portion. Okay. Actually, we always go into this simpler idea. Rarely we think about this hard. Okay. What if I have 4x squared square will be? Well, give it a try. What do you think 4x squared means? Okay, Joel says it is 4 times x times x. Let's try to understand and see whether it's correct or not. Okay, we know that if I have a number beside our algebraic variable, okay, it means that it is, in this case, 3 times x. So by right, it should be 4 times x squared. Right? By logic over here. Okay, and we know that x squared means x times x. So to even further break it down, it means 4 times x times x. So what Joel said is correct. Okay, 4x squared means 4 times x times x. Okay? So that's good. Then I want to ask, okay, what if I have brackets? And I write it like that. Okay, yes, Xavier. I do the 4x first, which what do you mean? Okay, 4 times x, and then what about the square? Okay, so he says 4 times x times 4 times x. Okay, so that's what you meant, right? Okay, so Emmanuel, you agree with Xavier? Yes, Emmanuel now. Yes, I'm sorry. You agree? Okay, but then this and this look the same one. Just that got bracket. Why is it the answer different? Okay, so now this is a very important part I need to address. Okay, very commonly people think it's the same, but it's not. Okay, what Xavier pointed out is correct because we do the brackets first. Inside the bracket means 4 times x, and then because of the square means that you repeat one more time. So there are 2 sets of it. So that's why 4 times x times 4 times x. So if actually, if I want to simplify this, 4I times 4, what do I get? What is 4 times 4? 16, right? Okay, then x times x, we know that it is x squared. Okay, so actually, bracket 4x squared means 16x squared. You understand? Okay, but of course to open it up, it means this. Okay, so I want you to recognize that this and this are equal, but this and this are not equal. Alright? Okay, let's do one last one. Okay, let me just write here. Notation and meaning. What if I have x squared y? Okay, x squared y, not sure what you think it means. X times y. Let's see if someone else agree. Brandon, you agree? X squared y means x times y. Do you agree? Yes, okay. Anybody disagree? Alright, so x squared means x times x. Then after another y means times another y. Okay, so this and this they mean are the same. Alright? You clear about this? Yeah? Now, moving on. Okay, let's look at understanding what are algebraic expressions. Okay, expression itself, okay, is like in English, okay, we have a phrase, okay, to express certain emotions or what else, a description, okay, that's what the meaning of expression is, okay. So when it comes to maths, okay, clearly I'm not going to care how the x feels, okay, or the y feels, okay, they're going to just be put into this thing called algebraic expression. So algebraic expression generally contain your letters, okay, that means the alphabet, okay, contain letters, your numbers, okay, and sometimes with operations. Alright, so whatever you see over here, all this notation, these are what we call expression. Even the meaning itself, okay, they are what we call expression as well. Okay, so very importantly, okay, also that there are no equal signs in expression. Okay, because later on when we go into the next chapter, things with equal sign, they are what we call equations. Right? Okay. So if I have a statement such that there's letters, numbers, and operations, and then there's equal sign in it, okay, that is what we have, what we call an equation itself. Okay. So for example, we have 2x minus 3xy plus y plus 7. Okay, this has numbers inside, has letters inside, there are operations as well, your minus and plus. Okay, in fact, there is multiplication hidden in it as well. Okay, so this in general is what we call an expression. An expression need not always have minus sign, plus sign. They can always stand alone like that as well. Okay, so with 3x, x squared, they are also called expressions. Okay, so in 2x minus 3xy plus y plus 7, right? Okay, need you to understand some terms that we will commonly use, okay, in describing an expression. We need to recognize that there are x and y inside it. So we say that it has two variables. Okay, so this word variables refer to the letters that are being used. Okay, and the variables are x and y. Okay. And then there are actually what we call four terms inside this expression. Okay. By the meaning of terms, it means that we're looking at it in parts. Okay. So we take the operation that's in front of the this section over here. So 2x is one term, minus 3xy is another term, plus y is another term, plus 7 is another term. Okay, so there are actually four terms. Okay, we say that the four terms are 2x, negative 3xy, y and 7. Just like positive numbers, okay, for positive numbers we don't usually put a plus sign in front to represent positive. So therefore, for y and 7, we don't need to put in the plus sign. Okay. Then there is a constant term as well. The meaning of constant term is that it is a number alone, there is no variable. So we see that only 7 is the one that has no variables with it, there's no x, no y. Just a number only, that is what we call a constant term. Okay. And then, in the term 2x, the coefficient, which is another word that I want you to know, okay, is actually 2. So the meaning of coefficient is referring to the number in front of the variable. Okay, number in front of the letter, right, that is what we call a coefficient. To extend this, if I talk about in negative 3xy, right, coefficient what do you think it is? What is the coefficient in the term negative 3xy? Who says that it is 3? Who says it's negative 3? Who is not sure still? Okay, don't worry. Alright, we start to identify patterns. So coefficient is the number in front of the variables. X and Y are what we call variables, right? Okay, the number in front is negative 3 because there's a negative sign over here. We have learned that negative numbers are numbers as well. Okay, so coefficient is negative 3. Okay? Okay, now, what about in Y? There's no number in front, but actually there's still a coefficient. What is that coefficient? Yes, Kitty? 1. Ethan, what do you think? 1 also. Anybody thinks that it's 0? Okay, so the coefficient in this case is actually 1 because just now I addressed that just writing the y itself, okay, it means 1y. I don't need to purposely go and write the 1. Okay, so the coefficient is 1. Okay, if it's 0, then it means 0y, which means 0 times y. So essentially it's 0, 1. Okay, so therefore in y the coefficient is 1. Okay? Yes, Joel? Yes, me. Okay, I think this is a lot for us to digest already. Okay, our lesson ends here also, right? Then for me, yes. Okay, so I want you to go back, okay, let these ideas, these words, okay, build this vocabulary, alright, because I don't want you come running to me say, there algebra, everything is algebra, okay? I want you to use proper terms, variables, okay, the word coefficient. These are important things that you need to put inside your mathematics vocabulary from now on. Okay? So end here for today. Oh, sorry, one more thing. Okay, could I trouble you to bring your maths file? Okay, what's the color for maths file again? Yellow, okay? Bring your maths file, your fat file on Monday itself. Okay, when I return you your WA, I do want you to directly be filed in. Okay, I hope that you have been filing your things already. Alright, so bring your maths file and also whatever things that are inside your maths file. Okay, so bring maths file on Monday. Okay.